Hello, this is Britt Caswell with another example video. In this video, I'm covering example 3 from section 3-4 in the SavvasRealize Algebra 1 textbook. So example 3 here is applying the explicit formula. So I want to start with a definition. What does it mean to do something explicitly? So in English class, this would usually means like to solve with a purpose, right? I remember as a kid I would get in an argument with my brother all the time because he would do stuff to explicitly upset me, right? He was purposefully going out of his way to be as annoying as physically possible. So when we are here in math class, we are going to be explicitly solving for a value, which means to do it with a purpose. So we call it this because usually we use it for large n values. So in my last video, you guys saw the recursive formula, right? Which is where, okay, you know your starting value and you know your common difference, and you can just keep plugging into that formula over and over and over, and it kind of steps you along through a function, right? But what if you want to find out the 5 millionth term in the sequence? You know, you're not gonna want to sit there and plug in 5 million values over and over and over again. So instead, we solve with a purpose. We use the explicit formula to very purposefully cherry pick the 5 millionth term out of the sequence. All right, and this is the general lookout for the explicit formula. Now notice that I don't have a second formula, right? Recursion needed 2 because you had to state what your A1 was. But the explicit formula has your A1 and your D built in, which is kind of cool. Alrighty, so here we are. We have the cost of renting a bicycle, and they want us to show it with an explicit formula. So the first thing is we need to identify our A sub 1. Okay, our A sub 1 is the value of the expression, or the number that's in the first position. So here's position 1, so A sub 1 is 26. So then what we have to do is we have to find our D. Our D is our common difference. So it's how much our output is changing for each hop. Okay, so to go from 26 to 38, that's a positive 12. From 38 to 50, positive 12. 50 to 62, positive 12. Alright, so recognize that this formula only works with arithmetic sequences. Okay, that means that it only works if that common difference is an addition or subtraction by the same value. So my D value here is 12. So then we just go to our sequence formula and we plug those in. So I say that A sub n, so to find the nth term, I need to take A sub 1, which is 26, and add to it n minus 1 times D, which is 12. So there it is. So now part B, if you notice, part B, they make the formula look a little different. And so the reason why they're doing that, the reason why they're changing it, is because in our next example, we are going to convert this to being slope-intercept form. So what I want to do is show you how to get from this equation, which is completely correct, to this equation, which is also correct. All right. So the way that we do that transition is I distribute this 12 to the parentheses. So 12 times n is 12n. And 12 times negative 1 is negative 12. And then the rest of the formula is staying the same. But now I have some like terms that I can combine, right? I have the 26 and the minus 12. So 26 minus 12 is 14. So I have a sub n equals 14 plus 12n. So that's where they're getting that formula, okay? And again, my original formula and this one, they're both correct. So then it says, what is the cost of renting the bicycle for 10 days? All right? And so this is nice because with the recursive formula, I would have had to plug in 10 times, right, to solve. But now I could just take the n value and replace it with the number 10. So let's go ahead and let's do that. So I am looking for the term a sub 10. Okay, so the value of the expression at 10 days. And so where the n is, I'm going to plug in a 10. So if I use my order of operations, I have to multiply before I can add. So 12 times 10 is 120. And 14 plus 120 is 134. So it would cost $134 to rent the bicycle. Ooh, I can't spell bicycle today, that was rough. To rent the bicycle for 10 days. Now the other perk to putting the equation like this is now you can see what is the initial cost. So this is the rental cost before any days happen. So how is an explicit formula related to a linear function? Well, they're essentially the same thing. Okay. And so the d value, the common difference that we had, is the slope of the function. And then when you distribute, right, and once you collect your like terms, then you get your y-intercept right away. Alright, so then question 3 here, I think this is your try it. Alright, it asks you to create the formula and then to find a sub 8, right? So remember, the explicit formula is right here in this lighter box. I'm going to write it a little bit below. So my explicit formula says a sub n is equal to a sub n plus 1 plus n minus 1 times d. Just double checking I'm not crazy. Okay. So let's go ahead and figure out these terms. So my, that should say a sub 1, not a sub n minus 1. I'm sorry about that. So my a sub 1 is $28 because that's what happens on the first day. Okay, so here's my a sub 1. Plus $2 for each day after. That's our common difference, right? So there's our d. And then this thing is asking for a sub 8. So let's take our a sub 1 value and plug it in. So I'm putting a 28 right here. And then I'm going to take my d value, which is 2, and plug it in right there. Alright, so here's my explicit formula. Now, if I want to distribute and collect like terms, I can do that. That's alright. So if I do that, I get plus 2n minus 2. And then if I collect my like terms, 28 minus 2 is 26 plus 2n. Okay? So now the second part of the question is asking for a sub 8. So where the n's are, I'm replacing it with an 8. So I have a sub 8 equals 26 plus 2 times 8. So 2 times 8 is 16. Ugh, I didn't quick math this. 6 plus 6 is 12. Carry my 1. That gives me a 4 here. So it would cost $42 to rent for 8 days. So there we have it. So that is how to use an explicit formula in Algebra 1. Until next time.